Welcome everyone to building Spring Data Neo4j 4.1 applications like a superhero. My name is Luanne. I work at GraphAware, and I'm part of the Spring Data Neo4j team at GraphAware. Okay. So how many of you have worked with Spring Data before? Spring Data 3? Spring Data 4? Okay, great. So for those of you who don't know, Spring Data is the most active Spring project today, and it offers you a convenient way to access databases, particularly, or well, most commonly NoSQL databases. It gives you consistent APIs to doing typical CRUD-like operations, executing queries, with a very consistent API. So typically you have POJOs which are annotated, and that really maps your domain objects to your underlying database. Some of the more popular implementations of Spring Data is, of course, Neo4j first, followed by JPA, MongoDB, and the likes. So Spring Data Neo4j 4.1. Why is it focused on performance? Spring Data Neo4j 3x and before were built to support Neo4j in embedded mode. As the Neo4j server was released, Spring Data Neo4j didn't really catch up with that. And so there were performance problems when you worked with it over the wire. So SDN4 was built, it was rewritten from scratch to provide a more performant way of accessing Neo4j over the wire. So SDN4 really only supports Neo4j over HTTP. But 4.1, which is the latest release, is able to connect to Neo4j with three drivers. One is HTTP, which operates, it uses Cypher over the transactional endpoint. And then you have the embedded driver, which you're used to seeing in SDN3. And then the Bolt driver, which we support as of 4 hours ago, really. So Bolt will, of course, work with Neo4j 3.0, which was released this morning. You can get a snapshot and try it, and it should just work. The other important difference between SDN4 and previous versions is that one of the design decisions was to separate the object graph mapper from Spring. So if you don't like Spring, you're not a Spring shop, you never want to use Spring, you can just use Neo4j OGM, which will work with any JVM project that you have. All the capabilities, well, more than 90% of the capability of SDN is built into the OGM. Okay, so we'll see, I think, on the next slide, a few things that sit as a layer in Spring, but all the functionality has been pushed down into the OGM, so you can just use the OGM and have all the power of Spring Data. Right. So the first feature is, of course, the fact that the OGM is separated, so you can now do object graph mapping from just the OGM library. You need not pull in any Spring dependencies. To be able to do this, we need to understand what your domain model looks like. So you have your entities which are annotated. That is all metadata that we use to translate your domain model into the graph. And we do that by scanning your classes, the classes that you tell us contain your domain objects. We really read those classes, but we don't use reflection, and that's why it's called vampire metadata scanning. There's no reflection. Your startup times are much faster, so your application as a whole will come up much quicker than had we used reflection to read all this. Smart object mapping refers to the fact that we are able to tell what has changed in your domain model and send only the delta over the wire to Neo4j for persistence. So if you've done actions, for example, that cancel each other out, you've added a relation and you've deleted a relation in the same sort of session, we will not send two operations to the graph which eventually evaluate to the same thing at the end. All this is done at the point of save. When you save your object, we will really figure out what has changed between what we know, which is what you've loaded, and what you've changed. And only that delta will be sent across the wire. So that also contributes to the fact that it's much more performant. This release is much more performant. All the changes to your domain objects are really managed by this thing called a mapping context, where we know what we've mapped, what we haven't mapped, and what we should be mapping. The mapping context is closely tied to a session. So a session represents your conversation with the database. Okay? What you do in that session is what the mapping context records and then finally sends across to your graph, to Neo4j to persist. Because it's tied to your session lifetime, you can operate this in various scopes. So one of them would be like your application scope. So you have a single session that runs throughout your application. It will know about whatever you've done in that entire application scope, what you've loaded, what you've changed, what you haven't. And therefore, the possibility of having, when you save objects, there's a high possibility that the amount of data you really send over the wire is much smaller because we already know everything else. This is the downside of this is that if you have a modification to these objects happening by other users, then your application-wide session scope may not really see those modifications till you load it yourself. So for at least web-based applications, the HTTP session scope or request scope, which closely mirror your true unit of work, is something that we would really recommend you assign to your session. So this is really a good balance between not knowing anything and knowing everything but missing updates. Okay? There are support for default converters and converters that you can add yourself. These are for types that are not native data types in Neo4j. So if you have an enum, you have a date, you have URLs, etc. We support many of these out of the box. So if you have a date, we will convert it for you. If you have an enum, we will convert it for you. You don't have to worry about it, but you have some kind of complex class that you need to store as a property on a node, then all you do is simply write a converter, and we will take care of converting that data for you when we write to the graph and converting it back when we load it from the graph. Okay, so all the above are all OGM features. Now, the next two are SDN only, and that's because they're really Spring Data concepts. So the concept of repositories, which allow you to do your CRUD operations in a very standard, consistent, springy manner. You will have methods out of the box to load data, load objects, save objects, find objects by ID, query objects. And the Neo4j template is slightly more low level if you don't use repositories and you want to work with Spring Data directly. Now, both of these are backed by the session in the OGM. So really, all the functionality that power repositories and the Neo4j template all that functionality belongs to Neo4j OGM. Custom queries is also an SDN feature. So your @ query annotation, which we'll see shortly, is an SDN-only feature. But again, it's backed by the OGM. So you can really use the query methods on the OGM session to achieve the same thing. Derive finders is something that you won't get in OGM because it's a Spring functionality where you do things like find by name and email, name and city maybe, right? So that's a Spring Data feature. Spring Data will really parse what that method name looks like and give you a set of properties that you want to filter by. But having said that, again, once you have the filters, this functionality is powered by the OGM. So if you were to drop one level lower, you can really achieve the same thing by writing some more code than you would with SDN. And finally, transactional support available in both. Some operations, we provide implicit transactions, so the equivalent of an auto-commit transaction. When you save objects, when you query objects, when you delete objects, we will wrap that in a transaction and send it across to Neo4j for you. But you can also manage it explicitly. You can open your own transaction, do whatever you want, commit at the end, roll back. In Spring, of course, you have the convenience of the transactional annotation. But in the OGM, you can just manage it yourself. Okay, the last feature is variable depth persistence. So usually when you have a node, okay, most often you are interested in things around that node, one hop away. What are things related to that node? Now you can either load just a node with its properties and then make multiple calls to the database to get things that are related. But if you're going to do that all the time, then it doesn't make sense. What you actually want is this. You want the first level connections, right? So this is a persistence depth of 1. the node and the first level relationships, but not their relationships. You can control this. It's fully customizable. Now, Spring Data / OGM assume very sensible defaults. When we load your objects, we load it to a default depth of 1, which is what you see in the center there. But you can change that. You can say, I want to load to a depth of 2, which will basically pick up the node in the center, the object of interest, and everything 2 hops away. And you can change that to whatever depth you like. That's available on both the OGM and SDN, of course. So it really indicates how many relationships you should traverse in the graph when you're loading, as well as saving data. The default for saving data is -1, which means when you save an object, we will find out whatever has changed in all objects that are reachable from the object that you're saving. So as long as your objects are connected, we will walk through all those objects till the end, collect what has changed, and persist it along with the object that you're actually saving. So you need not, if you've made changes to a lot of connected objects, you need not gather them all and save them. You can just save one of them, and because we can reach the others and we know what's changed, we will save everything. So the default persistence depth is -1, but you can change that as well. You can say, I just want to save level 0 or level 1, though we would really recommend that your loading and your persistence depth is in sync. So if you're saving only to a depth of 0, but then you're loading to another depth, you might find things out of sync. So that's the only thing to keep in mind. But variable depth persistence is a really important feature of SDN 4.1. OK, so what are we building today in the next 20 minutes? We're going to build a superhero graph, a very simplified domain model. What we have are characters that can either be heroes or villains. So you can see the character label, but they're also heroes or they're villains. So we've got 2 labels on these. Okay, you've got heroes and villains, which are either allies or enemies of each other. We don't care about the direction. The fact that you're an ally is good enough. You've got teams. So characters are members of teams. Characters are featured in both comics and games. And you also have movies that star various characters. Now, we've taken the decision to store the actor that actually played that role as a property on the relationship, so we can show you what certain entities look like. OK, so we'll get into code now. The most important node that we have in this entire graph is really the character, because everything is connected to the character. So this is a portion of the character class where what you see is, of course, the fact that it's called character. And then you've got, and then you've got this annotation called node entity with label equal a character. Now, that's optional. If you don't have the annotation, we will still know that character represents a node, and we will assign to it a label called character. The annotation is there in case you want a different label. And really, we really recommend that you use annotation so that your graph is immune to refactoring. If you change your class name, you change your property names, you forget about your graph, then you would be in a very unhappy state. So use annotations as far as possible to leave your code kind of clean. That's, of course, the label. The next thing you will notice is the fact that you have a graph ID annotation. Now, the graph ID really is the Java lang long that attaches your entities to the graph. Okay, internally, it's the internal node ID or the internal relationship ID. And that is what SDN uses to figure out where this entity belongs in the graph. Now, it's not usually recommended that you use internal node and relationship IDs as your own keys. So you're free to provide your own keys. Okay, in this case, it's also called ID, but it's not annotated. So this long ID is really a property on your node. You're free to set unique constraints on it, et cetera. It just behaves like a regular property. Apart from that, we've got all the other properties that we want on the character node. So this is the node and its properties. Look at some of the relations. Okay, so the first one. So relationships need not have an annotation, though again we strongly recommend that you create a relationship annotation for 2 reasons. One is If you want sensible-looking relationship types and you don't want them derived from what your collection is called, which may not make sense some of the times. And secondly, the ability to specify a direction. Now, in this case, both the allies and the enemies are undirected. We don't care whether it's incoming or it's outgoing, but we just care that there's a relationship between these two, and that indicates that they're enemies or they're allies. So you'll see that both of them have a set of characters, okay, because finally they're all characters, irrespective of whether they're heroes or villains. So those define relationships from characters to other characters, a many-to-many relationship. Okay, that's the enemy of. Then you've got the fact that a character belongs to a team. Character is a member of a team. Here you can see there's no relationship type defined. So we will assume that this is an outgoing relationship. Okay, so if most of your relationships are outgoing, you need not define it. So again, this is a set of teams that a character belongs to, because of course superheroes can belong to many teams at various points in history. Games and comics. Now, the thing to note here is that you can have the same relationship type with different end nodes. Okay, so in one case, you've got featured, character is featured in a game, so a node with a game label. And in the other case, you've got a character is featured in a comic, and the comic is a completely different type of node. But this is fine. In SDN3, you would have to specify what the end type was. In SDN4, we are able to tell what maps to what. So you can safely use this with no problems. Same relationship type, different end node. Now, if you had the same relationship type and the same end node, yeah, then we would have problems. But if you do this, you're perfectly fine. The last kind of relationship is the rich relationship between a character and a movie. It's a rich relationship because we have the property, the role on it. So you'll see that this is a stars relationship. It's an incoming relationship. If you have incoming relationships, you must indicate to us that it's incoming. Okay, that's like non-negotiable. So relationship incoming will tell us that the relationship, the role, the stars relationship is coming from the movie node to the character node via a role class, and we'll see that a bit later. Okay, so that was character. Now we've got hero and we've got villain that are just specializations of that character. They have different labels. For this example, we don't really have many properties that distinguish them. So it's sufficient to extend these two, set their labels. So you've got hero, you've got villain, and SDN will make sure that all your villain nodes have two labels, a villain and a character, and your hero node will have a hero and a character label. Okay, so this is currently the only way to have multiple labels assigned to your nodes in SDN or the OGM. Okay, so we'll walk through the rest of the classes quickly. I do want to show you all the classes to give you an idea of what you can build in 30 minutes. So team, the same thing applies. Node entity, give it an annotation, set a label on it. Even though your class name is the same today, it may not be tomorrow. You have your graph ID, and generally the same set of stuff. Properties, your relationship, which is the reverse relationship to the character. Okay. Again, note that it's incoming. The previous case, it was outgoing. Here, it has to be incoming. Or if it were undirected, then you would just say that in both places. Comic, same stuff, annotated with node entity. Make sure you remember to assign it a graph ID. And then the only difference here is that you see this date field. By default, if you don't annotate it, we will store your date as a string. In some cases, you may not like that and you want to store it as a long, in which case you annotate it with date long, and we will make sure that we convert this date to a long property on your node. Relationship is really the same. Binding is an enum, right? So you don't have to supply a converter to it. That's what it looks like. This is the binding of your comic book. You don't have to supply a converter because we already have this converter built in. So if you have an enum that we can recognize, by recognize I mean it's scanned with your domain packages, we will automatically convert the enum to a string property and store it on your node and convert it back to your enum when you load the entity from the graph. Okay, so game. So now you should be pretty familiar with most of the annotations. Again, you have a platform, which is an enum. In fact, this is a collection of enums. So again, we will serialize your enum to strings. So you'll have an array of strings stored as a property on your node, and we will read it back as well. So you don't need to annotate this at all. And finally, we have movie. The interesting thing in movie is here, the URL. Now, we don't have a default converter for a URL. So if you want to convert a URL to a string, then you would end up writing your own converter, which you specify like this, with the @convert annotation and the class that really represents that converter. And it looks something like this. You simply implement the attribute converter interface, and then there are two things you have to tell us. What should it be in the graph, and what should it be when we read it back from the graph? So you can see it's very simple. It converts it to a string, from a string, converts it back to a URL, and that's it. Okay, and this will work with even the Spring conversion service. Okay, they all play nicely together. Finally, the role, which is the rich relationship between the character and the movie, because it has a property. So only if you have relationships which are distinguishable from each other because they have varying properties, that's the only case that you would really model it as a relationship entity. The annotation for a relationship entity is mandatory. It's not optional. You must define it. You must tell us what the relationship type should be, which is stars in this case. Okay, so that's the annotation. And then you've got an ID. Now, in this case, I don't particularly have my own primary key for a role. Okay, I don't care about it from my application point of view. So I'm just going to say I have this long ID, which we will really recognize as the graph ID. If you have a long property called ID, we will pick that up as your graph ID, provided you haven't annotated anything else. Okay, so you can either annotate this or not. This is an example of when the graph ID is optional. After you have your ID and your annotations, of course, you have to have a start node and you have to have an end node. So what is the start of this relationship? It's from a movie to a character. Okay, and the only property it has, apart from its internal ID, is the actor that played the role in this movie. Okay, so that's the property. So that's why you'll see that in your movie class and character class, you don't reference them directly. You always reference them through the relationship entity, because you really say that a character plays roles in movies. So the role really sits between your character and your movie. Okay, so repositories. Don't read the query. I will tell you what it does. It's kind of simple but long. The first thing, so your repositories are your standard Spring Data repositories, with the only difference that you now extend graph repositories. It gives you all the things that you expect from Spring Data out of the box. So find by ID, save, load, etc. The things that you will want to add to it are derived finders. So find by name like. So on your character class, you have a property called name. Now, you need not write a cipher query to find characters by name. You use a derive finder, and we will form the query for you, where we will really match by label, match character, where name equal to, or in this case, like. So where name like whatever you supply. You'll see that in this case we are returning T, because the application that we'll be showing you really has two kinds of searches. One is when you just search for all characters, and then I want to search for heroes, or I want to search for villains. Because these classes extend each other, and their repositories do as well, the find by name like will operate differently depending on whether you use it from a hero repository or from a villain repository, because it will really filter by the label. Custom queries look like this. You have @query and then a large cipher query. Now what this does is we are looking for related characters. So given a character, which other characters might you be interested in? And for the purpose of today's discussion, we are looking at characters that are enemies or allies of each other, or in the same team, appear in the same comic book, acted in the same movie, and so on and so forth. Okay, so you will return whatever you need to return at the end of the day, and Spring Data, if it's a domain entity, we will map it to your domain entities and give that back to you. Okay, so that's custom query. These are what the hero and villain repositories look like. They don't need anything else in them for this application. You simply extend your character repository, and you will have your derive finder for free, as well as, of course, your custom queries. Okay, so to be complete, since we do want to show you that you can build an application in 30 minutes, service, very straightforward, inject your repositories, delegate your calls, and you're done. Controller, the same thing, just sits on top of your services. So I'm not going to go through this. It has nothing to do with Spring. The last piece that you need to have to get everything running is configuration. How do you configure Spring Data or the OGM? The easiest way to do this is auto-configuration. So you supply an ogm.properties file, which must have at least two things. One is which driver are you using? Okay, so HTTP, embedded, or Bolt, and the URI to the database. In case of embedded, it will be a path to the database. Bolt will have a Bolt URI, and HTTP, of course, has a very familiar URI up there. If you don't want to auto-configure, so if you don't want to supply a properties file, if you need to pull your username and password from elsewhere, or get your URL from an environment variable, very common on systems like Heroku, et cetera, then you will set up your configuration explicitly. So through Java, it's very simple. You basically get your driver configuration, set the class name, set the URI. You pull this from whichever sources you might have, and you're ready to go. For SD, so that is OGM, which is also required for SDN, but SDN requires something a little bit more. One is you must extend Neo4j configuration, okay, the Neo4j configuration class. Then, of course, you've got the familiar repositories, so enable Neo4j repositories, and that's your package, of course, that contains all your repositories that extend from the graph repository. And then you have the session factory. So the session factory is really the entry point into everything. It really sets up all your metadata, okay? And it's responsible for supplying this metadata to every single session that you create and use in your application. What you need to pass to it are all the packages that contain your domain information. Okay, so the session factory is typically application scope. There's no advantage if you were to create it every session, because it really does scan all your packages when you instantiate that. From the session factory, you get your session, which is the thing that you use for everything else, really. Okay, so querying, loading, saving, everything happens out of the session. This is the scope that we spoke about earlier, applicable in SDN. This is HTTP session scope. You can change that to request if you like, depending on what your application looks like. Okay, and the scope, the lifecycle of that session will be managed for you. Okay, so that's all the code we have to produce the following application. I'm just going to switch out for a while. Right. So this is the Graph Hero search that our superhero Martin from GraphAware has designed. You have a search, so we search by man. Okay, and what you get are, this is the derived finder, find by name like. Okay, so we've supplied man, and you get a list of characters in this place. But if you were to filter by, let's say, villains and search again, then this is where the villain repository kicks in. So the additional filter now is the villain label on the node, which is why you don't get the heroes. And the same thing applies to heroes as well. So you've got your hero repository, which will give you only heroes. So one derived finder will power all these three kinds of queries because you have this kind of inheritance structure. What are the other things that we coded? So this is really load by ID. So find by ID Batman, and you get Batman. This is depth 1. So you've got all the properties, which are things like the name, and you've got the first level relationships, which are his teams, allies, enemies, and then, of course, you can drill down into things like the movies he's acted in, the games, etc. Click on a movie, and these are your enums, the rating. Okay, this is your URL, which will open up IMDb. The custom query, which was related heroes, powers this portion of it. Okay, so these are all kinds of characters that have interacted with Batman in some form or the other. Okay, so 20 minutes, you can build a fairly decent application with not too much code, really. So I'm going to switch back for a minute. Okay, so that covers, well, almost everything you need to know to get up and running with SDN, but of course you'll want to read some more about it. So where do you find information? The documentation is currently the best source of information about SDN. There are also OGM docs, which talk about the OGM side of things and not necessarily Spring things. The code is all available on GitHub. We're happy for pull requests, issue logs, etc. And there are quite a few sample applications at Neo4j examples. If you look for SDN4 or you look for the OGM, there is one OGM application. Okay, so where do you find us for the rest of today? So Vince Bickers is here. He really designed the entire system. So you can find him today at the GraphAware stall, at the GraphAware booth. Me, you should know by now, and you'll find me around. Adam isn't here with us today. And of course, finally, we have our fearless leader, Michael Batman, who isn't here, unfortunately, right now, but that's him. So you can find him around later as well. So we're all available today if you have any specific SDN or OGM questions. If you need help, Stack Overflow is really the best place to go. Use the appropriate tag so we find you quickly. Spring Data Neo4j 4, Neo4j OGM. Neo4j SDN channel on the Slack group is fairly active, so feel free to ask questions there. Email us directly. We're springdataneo4j@neotechnology.com. You can open issues yourself directly in Jira, which is a Spring repository, or on GitHub for the OGM. Follow GraphAware on Twitter for pro tips, and we have quite a few SDN-related blog posts on our GraphAware blog. So you're a graph hero now. At the end of this, we'll be really happy for you to head over to our GraphAware booth and take a picture as a graph hero, because I think you've earned it after sitting through 30 minutes of Spring Data. And that's all we have. So thank you very much.